Robots are being used all over the world to simplify human tasks, but the math behind robotics is often overlooked. Imagine here, we have a small town, and on one corner of the town we have a bakery. Every morning the bakery is going to need a shipment of chocolate so that it can create the various pastries throughout the day. The problem is, none of these townsfolk want to get up early enough to deliver the chocolate to the bakery. So they have an idea. They decide to build a robot to complete the task for them. They all decide that no matter where the robot is in the town, it should be able to reach the bakery, and no matter what, it should be able to get the chocolate successfully to the bakery in the morning. Now they decide that because of this, the robot needs to know where it is, because that's the only way it's going to know where the bakery is. So they decide to put up 3 towers on the other 3 corners of the town to help the robot get a reference point of where it is relative to the bakery. Now let's go ahead and see the real thing. Just like with our paper model, we see the bakery, Tower 1, Tower 2, and Tower 3. Also, because we'll be dealing with distances a lot, it's important to establish a grid which has dimension a by b. Also, we'll establish a coordinate system which will be on that grid. The robot can then use the onboard sensor it has to measure the distances to towers 1, 2, and 3. And now for the math. If the robot's initial position is x, y, we can use the Pythagorean theorem to generate these 3 formulas. We can then solve for x and y in terms of a and b, which are the size of the coordinate grid, and d1, d2, and d3, which is the 3 distances the robot just measured to the 3 towers. More importantly, we can solve for x go and y go, which is how far the robot needs to go in the x and y direction still to reach the bakery. So theoretically, we should be able to start the robot at any point in this grid, and using these formulas, the robot should be able to travel the required distances and reach the bakery no matter what. Let's go ahead and see the results of 4 trials where we start the robot in different locations each time, and see if it reaches the bakery. Until next time.